Hello everyone. In this video, we are going to discuss about quantum numbers. Quantum numbers are a set of integers which defines the structure of atom and stability of the atom. Basically, there are four set of quantum numbers available in the atomic structure. First one is principal quantum number, and another one is azimuthal quantum number, and magnetic quantum number, and spin quantum number. Okay. These three quantum numbers, azimuthal quantum number, magnetic quantum number, and spin quantum number, is basically depends upon these three are basically depends upon principal quantum number. Why? Because it indicates the energy of the orbit, energy of the orbit. So due to that energy of the orbit, the shape, the size, and the spin of the electron is governed by the principal quantum number. So these are interrelated to principal quantum number, and it's denoted by n. Principal quantum number is denoted by n. It defines the energy of the orbit. And another one is azimuthal quantum number. So, azimuthal quantum number defines the subshells in the main energy level or orbit, energy level or orbit. So how many subshells are present in main orbit, it is defined by the azimuthal quantum number. And the magnetic quantum number defines the shape of the subshell. Shape of the subshell, which is called as spatial orientation. Spatial orientation of orbital. It is defined by magnetic quantum number, and spin quantum number is defines the spin of the electron. Okay, azimuthal quantum number is represented by L, and magnetic quantum number is represented by M, and spin quantum number is represented by S. Okay, we can discuss about these four quantum numbers in single box. Say suppose the principal quantum number. The principal quantum number is starts from 0 to infinity. So it has a values of 0, 1, 2, 3, 4 up to so on. It has a value from 1, not from 0. It has a value from 1 to infinity. And the azimuthal quantum number depends upon the principal quantum number, and the azimuthal quantum number relates upon from 0 to n minus 1. It depends upon the principal quantum number. Its value ranges from 0 to n minus 1. And the magnetic quantum number depends upon the azimuthal quantum number, and it values depends upon 2l plus 1. And the spin quantum number has no units. It depends. It's only relies upon positive or negative sign, positive half or negative half. So let's consider that the principal quantum number is started from n equals to 1. Then the value of, if I am writing n, l, m, and s. So if the value of principal quantum number is 1, then the azimuthal quantum number becomes n minus 1. So from it value depends upon n minus 1, 0 to n minus 1, up to 0 to n minus 1. So so here we got n equals to 1. So 1 minus 1 equals to 0, and the magnetic quantum number becomes 2l plus 1. Here the L value is 0. So that means magnetic quantum number becomes also 1, But for the all purposes, when the L value becomes 0, also M value also becomes 0. It indicates that that the shell is that the shell is s orbital. If L equals to 0, that indicates that the orbital is s shell. A spin quantum number indicates that the energy the spin of the electron which resides plus or minus 1 by 2. That means plus 1 by 2 and 1 minus 1 by 2. That means when the n value equals to 1, the total number of electrons are 2. That means there are 2 electrons in this first orbital, in plus of and minus of. When the n value equals to 2, n value equals to 2, L value becomes n minus 1. That means 2 minus 1. So that indicates there is 2 possible values for the orbitals. If the 0 indicates S and 1 indicates P, and the M value resides from 12 plus 1, that indicates that 2 into 1, 2 plus 1, 3. So that means 3 possible orbital orientations will be available in this energy level. That means plus 1, 0 and minus 1. And for the perspective, if for one orbital there are 2 possible electrons with plus and minus 1 by 2. There are 3 orbitals present here, minus 1, 0 and plus 1. That means we got a total of 6, but it's not the case. In the s orbital there are only 2 electrons present. In p orbitals there are 3 subshells present. It is for only p orbital. For the s orbital it will becomes 0. So that means for the 0 orbital position it occupies 2 electrons, and for the 3 orbital positions it occupies 6 electrons. That means total 8. And if the principal quantum number becomes 3, and then the azimuthal quantum number becomes 0, 1, 2. Why? Because it depends upon n value, n minus 1, 0 to 2. So if the if 0 orbital presents, 0 position indicates s orbital, and 1 position indicates p orbital, and second position indicates d orbital. So similarly, in the s orbital there is only 1 orbital present. In the p orbital there are 3 orbitals present, minus 1, 0 and plus 1. Plus 1, 0, minus 1. In the d orbital there are 5 possible states. Why? Because 2 into 2, 4. If the substitute the value of L as 4, 2 into 2, 4, plus 1, it becomes 5. So that means plus 2, plus 1, 0, minus 1 and minus 2. Okay, these 5 orbitals are present when the azimuthal quantum number becomes 2, and the electrons occupied in 0 first s orbital is 2. All electron occupies plus or minus 1 by 2. Each and every orbital occupies only 2 electrons, 2 pair of electrons. It indicates that for the s orbital it will becomes 2, and for the p orbital it becomes 6, and for the s orbital it becomes 10. So that means total 18 electrons will occupied when the orbital has the energy of 3. That means principal quantum number, if the principal quantum number is equals to 3, then the total number of electrons becomes 18. And if we continue further, if the value principal quantum number becomes 4, then the azimuthal quantum number becomes n minus 1. That means 0, 1, 2 and 3. 0 indicates S, 1 indicates P P, 2 indicates D, and 3 indicates F. So, and we can clearly rely upon the orbital positions such that if in the s orbital it will consist only one orbital. For the p orbital it has 3 orbitals, -1, 0, +1. For the d orbital it becomes -2, -1, 0, and +1, +2. And for the f orbital it becomes from -3 to -3, -2, -1, 0, and up to 1, 2, 3. So all are the electrons are occupied in this state are +1/2, plus or minus 1/2. Each individual orbital consists 2 pair of electrons. For the s orbital it becomes 2, for the p orbital it becomes 6, and for the d orbital it becomes 8, and for the f orbital it becomes 14. So if we add up together it will becomes 32. So that means whenever the electron consists of 32 electrons, that means the energy of that principal quantum number becomes 4. These things we have to consider for the concept point of view, and we have to make sure that these orbitals consist of how many subshells. This s orbital consists of how many subshells, and p orbital consists of how many subshells, and d orbital consists of how many subshells. If we are aware about these things, we can ultimately find how much number of electrons can be resided in the main energy level. Another formula is we can directly calculate the total number of electrons. If the n value is given, that becomes 2n square. If you substitute 2n square, you will get the number of electron associated in that energy level, main energy level. Say suppose if in case n equals to 1, 1 square equals to 1, so 1 into 2 equals to 2. That means when the n equals to 1, it becomes 2. That means the number of electrons are 2. If the main energy level equals to 2, that means and the total number of electrons becomes 2 into 2 square. 2 square equals to 4, 4 into 2 becomes 8. Like that we can do for all the main energy aspects. And another thing we have to consider, the s orbital indicates that it is spherical shape. It is spherical shape, and p orbital indicates dumbbell shape. Dumbbell shape, and d orbital indicates double dumbbell shape, bell, and f orbital indicates fourfold dumbbell. Okay, there is no need to remember the diagrammatical concepts in the exam point of view, but you have to remember the concepts, all of this. Okay, if you want to know that the energy configurations, you can clearly see here that s orbital is in spherical shape, and f orbital indicates 3 type of orbitals associated in this p orbital, px and py and pz, and the d orbital consists of 5 energy states: dxy, dyz, dzx, dx square minus y square, dz square. Okay, and another concept is Euler diagram. We can it's not need to explain that much detail for the Euler diagram, but we have to remember the thing that the sequence order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and 5s. It will ends up here: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. In this Euler diagram, it indicates that the first orbital has least energy and the last orbital has highest energy. Least energy and highest energy, so that we can formulate the three concepts for the arrangement of electrons in this orbital. First one is Aufbau. Aufbau indicates that only we can arrange the electrons with the increasing order of their electrons. Aufbau principle indicates that electron filling increases from lower orbit to higher orbit. It indicates from lower orbit to higher orbit. And another concept is we cannot fill the electron from the 2s instead of 1s. After only when the 1s orbital is completely filled, then it's possible to move on to the 2s orbital. This is known as Aufbau principle. And the second thing is Hund's rule. It indicates that there are equal energy states in the orbitals, like p orbital. It indicates that it specifies that how to fill the electrons in equal energy states, like in p orbital and d orbital. In p orbital we have three subshells: px and py and pz. Both three orbitals has the same energy content, so that it becomes ambiguity to fill the electrons in this type of equal energy levels. So that's why we have to focus on the concept of Hund's rule. It suggests that after in the equal energy states only pairing will occur. Only equal energy states has equal amount of electrons. That means these orbitals must contain one electron each. After only we can get the pairing possible by next electron. And the last concept is Pauli exclusion principle. It indicates that there is only one orbital consists of two pair of electrons only. Two electrons only, two electrons only. It exists only two electrons only. For each orbital it consists only two electrons. This indicates that no two electrons will have same set of quantum numbers. No two electrons will consist of four set of quantum numbers. That means regardless of four quantum numbers, one will be differ for two electrons. So it will indicate that will indicate the uniqueness of the electron, that is different from one another.